All right, well, hello to my seventh grade friends. We are continuing right along here in chapter 13 with a focus today on when zero is used as an exponent and when we have negative numbers used as an exponent. So there's going to be a couple things that I want to point out. And the first one here has to do with a zero as an exponent. Now, anytime there's a zero as an exponent, the whole thing just equals 1. It doesn't matter if it's 2 to the power of 0, it will equal 1. 3086 to the power of 0, it will equal 1. Anytime there's something to the power of 0, it equals 1. You'll want to remember that. Now 12 to the power of negative 1. Whenever we have a negative exponent, I want to make sure we understand that that does not mean that it is a negative number. Okay? When we have positive exponents, the number gets exponentially bigger. When we have negative exponents, this is still going to be a positive number. It's just going to get exponentially smaller. So we have 12 to the power of negative 1. That means that what I have here is this becomes a fraction with 1 at the top, and what I put at the bottom is 12 to the power of 1. It's always 1 that goes at the top, and then it's 12 instead of negative 1, it's to positive exponent of 1. 12 to the power of 1 we know is just 12. So the final answer here is 1 over 12. Moving right along, now we have a multiplication problem here. Negative 15 to the power of negative 2 times negative 15 to the power of 2. The rule applies that we've used previously. Same base number means you just add the exponents. So we have the same base number here of negative 15, so we're just adding the exponents of negative 2 plus 2. Well, that leaves me with negative 15 to the power of 0, because negative 2 plus 2 is 0. As we talked about in the first example, anything to the power of 0 equals 1. So the final answer to this problem is 1, because it's negative 15 to the power of 0. Moving right along. Here we have another multiplication problem. 10 to the power of negative 4 times 10 to the power of negative 6. Well, we know that this is going to equal, because we have the same base number, negative 4 plus negative 6 is negative 10. So it's going to become 10 to the power of negative 10. But we have a negative number, so it needs to be turned into a fraction. Now remember, when we turn a negative exponent into a fraction, our numerator is going to be 1. Okay? And then, since it's 10 to the power of negative 10, it's going to be 10 to the power of 10. So it's going to be a fraction that's going to end up being 1 over whatever 10 to the power of 10 is. Now, depending on your calculator, I'm going to be interested to see what happens here. Quite honestly, I'm not sure if I have enough room for this number. Nope, it's just going to say 1. It gives me kind of an error sort of a thing. But if we think about it, we have 10 multiplied out 10 times. If I use the zeros trick, all the ones mean the first number is going to be with 1, and then there's just going to be 10 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Essentially, 1 over 10 billion is what that works out to be. All right? So, let's move along to the next one. 1 times 3 to the power of negative 3 times 3 to the power of 5. Well, if I think about the fractions, I know that 1 times 1 is 1. And since these have the same base number, I'm just going to add the negative 3 and the 5. Well, negative 3 plus 5 is 2. So that leaves me with 3 to the power of 2. But I can figure out what 3 squared is, because that's just 3 times 3. So that's 9, which means my final answer here is 1 over 9. Let's look at this last one here in this section. 4.1 to the power of 8 being divided by 4.1 to the power of 5 times 4.1 to the power of 7. Well, first I want to combine these. Same base number, 4.1. So since this is a multiplication problem, I'm going to add 5 and 7. 5 plus 7 equals 12. So this is going to leave me with 4.1 to the power of 8 over 4.1 to the power of 12. So now I just have a division problem. 4.1 to the power of 8 divided by 4.1 to the power of 12. And so that's a subtraction problem. 8 minus 12. And that gives me negative 4. So that leaves me with 4.1 to the power of negative 4. Well, that's a negative exponent, so I'm going to have to set that up as a fraction with 1 as the numerator. And since it's 4.1 to the power of negative 4, I know it's going to be 4.1 to the power of positive 4. So I come into my calculator, I'm going to enter in 4.1 exponent 4, and then equals, and that's going to give me 282.5761. So my final answer is going to be 1 over 282.5761, as I can see right there on my calculator. So that is evaluating the expression, taking that and actually solving it, getting a number as much as you can. You see in this section we didn't have any variables, and you won't in this section. So you just need to come up with an answer. All right, now our next section tells us to simplify, write the expression using only positive exponents. So our job here is basically to simplify it as far as we can, but when we can't figure it out, actually solve it, we need to make sure we're only using positive exponents. We're not allowed to leave numbers with negative exponents. So let's think 19x to the power of negative 6. Well, I can think about this. Remember, a number right next to a variable is multiplication. So I can think of this one as 19 over 1 being multiplied, and I can take my x to the power of negative 6, turn that into a fraction, 1 at the top, and x to the power of 6 at the bottom. Then I just multiply it. 19 times 1 is 19. 1 times x to the power of 6 is x to the power of 6. I get 19 and x to the power of 6. Here I have 14a to the power of negative 5 divided by a to the power of negative 8. Well, if I was to envision a number here, there'd be a 1. We don't put a 1 in front of a variable, so I'm kind of thinking 14 divided by 1, and well, 14 divided by 1 is 14. So 14 is somehow going to be part of my answer. Then I deal with a to the power of negative 5 being divided by a to the power of negative 8. They have the same base number, a, so it's just negative 5 minus a negative 8, which is essentially the same as negative 5 plus 8, which happens to be 3. So a to the power of negative 5 divided by a to the power of negative 8 equals a to the power of 3. And I have simplified that as far as it's going to go. Let's look at this next one. 16y to the power of 4 being divided by 4y to the power of 10. Well, the first thing I want to do is deal with the numbers. 16 divided by 4. Well, 16 divided by 4 is 4. Then I'm going to do y to the power of negative 4 being divided by y to the power of 10. Well, same base number, so I just subtract the exponents. 4 minus 10 gives me negative 6. So I end up with 4y to the power of negative 6. But my directions say I have to write the expression using only positive exponents. So now I need to multiply this one the same way I did that one. So this is actually going to become, I have to do the multiplication of 4 over 1 for the 4 times 1 for the negative exponent over y to the power of 6. All right, I've taken the y to the power of negative 6, made it 1 over y to the 6. 4 became 4 over 1. Now I just go ahead and multiply them. 4 times 1 is 4. 1 times y to the power of 6 is y to the power of 6. I end up with 4 over y to the power of 6. All right, moving right along. Here now we have a multiplication problem. 3x to the power of 6 times 8x to the power of negative 6. Well, the first thing I address is the numbers. 3 times 8. Well, 3 times 8 is 24. All right. Now x to the power of 6 times x to the power of negative 6, same base number, x, so I'm just adding the exponents. 6 plus negative 6 is 0, so it's 24 times x to the power of 0. Well, as we talked about, anytime there's something to the power of 0, it equals 1. So it doesn't matter what the value of x is. X to the power of 0 is 1, which means that all I'm doing is 24 times 1. Well, that can be simplified. We know what 24 times 1 is. 24 times 1 is 24. All right, a couple more examples. Another multiplication problem here. 7k to the power of negative 2 times 5m to the power of 0 times k to the power of 9. All right, well, here's a whole lot of things going on here. All right, first off, what I want to do is I want to look at my whole numbers. And I see 7 and 5. Well, I know what 7 times 5 is. There's no whole number here, just 1. 7 times 5 is 35, so that can be part of my answer. Now I look at things that have the same base number, and I'm saying, okay, k to the power of negative 2 can be multiplied by k to the power of 9. They have the same base number, k, so I'm just adding the exponents. Negative 2 plus 9, well, that's 7. So that's going to become 35k to the power of 7. So that took care of that and that. The only thing I haven't addressed yet is this m to the power of 0. Well, it's to the power of 0. So anything to the power of 0 equals 1. Okay, so m is not going to be included. It just means 35k to the power of 7 times 1, because that's what this is. Anything to the power of 0, doesn't matter what m is, it equals 1. Well, 35k to the power of 7 times 1 is just going to be 35k to the power of 7. That's my final answer, 35k to the power of 7. All right, one more. I want to clear the space on my original board here first. All right, thank you for your patience. All right, and we're going to set this up here. This is going to be 12x to the power of negative 4 times 4 to the power of negative 2 times y to the power of 3. And it's all going to go over x to the power of 2 times y to the power of 5. All right, that's what's going to happen here. Well, there's a lot going on here. So first, let's look at things that can be combined. And so I'm thinking, well, x squared and x to the power of negative 4. So I'm thinking, well, 12, okay, 12 divided by 1, because that's what would be here, would be 12. All right, and then x to the power of negative 4 divided by x to the power of 2 would be x to the power of negative 6, because negative 4 minus 2 is negative 6. So this would be 12x to the power of negative 6. All right, well, now let's deal with the y to the power of negative 3 divided by y to the power of 5. Okay, same base number, so it's just 3 minus 5. 3 minus 5 is negative 2. So part of this has got to be times y to the power of negative 2. The other part is this 4 to the power of negative 2. So we've taken care of that. That's the 12x to the power of negative 6. We've taken care of that. That's the y to the power of negative 2. We have 4 to the power of negative 2. And remember what that's going to be. That's going to be a fraction with 1, because it's a negative exponent that we turn into a fraction with 1 as the numerator. 1 over 4 to the power of 2. Now I know what 4 to the power of 2 is. That's 16, because 4 times 4 is 16. So I'm going to just go ahead right now, save myself a little time later, and make that 16. All right, so now I have y to the power of negative 2. That also needs to be a fraction. So I can bring my 1 over 16 straight down. I know my y to the power of negative 2 is going to be a fraction with 1 as the numerator, and the denominator is going to be y to the power of 2. Now let's think about 12 times x to the power of negative 6. Well, if I want to make 12 a fraction, that's going to be 12 over 1. If I want to make x to the power of negative 6 a fraction, okay, that's going to be, it's a negative exponent, so it's going to be a fraction, 1 over x to the power of 6. And now I've got all kinds of stuff going on here. I've got a long multiplication problem here. Well, let's just simplify that. 12 times 1 times 1 times 1 equals 12. That's not hard. Well, I know that 1 times 16 is 16, so I can just put 16. And then I have x to the power of 6, y to the power of 2. So that's just going to become part of my answer. All right, and then I'm thinking, well, I can actually simplify 12 over 16 by dividing them both by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. My actual final answer will be 3 over 4, x to the power of 6, y squared. All right, 7th grade. Have a good day. We'll talk to you later. Bye.